All right, so the nice thing is that if we do FOIL these out, again, this is where we're at. If we do FOIL these out, there's going to be some cancellation, and that is freaking great, okay? So, yeah. Yep. So x times x, what's this gonna look like? Let's use a different color so we can track this a little easier. We got x times x, that's gonna be x squared. Then we have x times 3, it's gonna be 3x. Then we have negative 10 times x, which is negative 10x. And then we have negative 10 times 3, which is negative 30. Beautiful. Then over here, this is a negative 1 on the front, so let's just say negative 1 times now whatever is in these parentheses, okay? So it'll be the opposite of whatever this is. Or we can distribute it, doesn't matter. Ahead of time. Anyway, we get x times x, which is x squared. We get x times 2, which is 2x. We get negative 6. Oh yeah, let me make sure I draw that, okay? We get negative 6 times x, which is negative 6x. And we get negative 6 times 2, which is negative 12. And if we distribute that negative 1, what we have is negative x squared minus 2x plus 6x plus 12. And as you can see, basically what that negative 1 is doing is it's flipping the signs of everything within those parentheses, if that makes sense. And over here, we'll drop this down. We have x squared plus 3x minus 10x minus 30. Now what's great here is we're going to have some cancellation. These x squared terms go away because x squared minus x squared is 0. Then we have 3x minus 10x. This is negative 7x. Minus 30, plus 4x. Because if we add negative 2x plus 6x, that becomes 4x, plus 12. And all of this, again, these are all still equal to 0. You could have done this without moving them over to the other side of the equation. That was my bad, but you're going to end up with the same result either way. Because you have to move them in the end, ultimately. And this is equal to 0. Okay, so here's where we have negative 7x plus 4x. This becomes negative 3x. And this is minus 30 plus 12 is negative 18. And if we move one of these to, this is equal to 0. So let's move that 18 to one side of the equation. What we get is negative 3. X is equal to positive 18. Divide out this negative 3. Negative 3. And what we find is that x is equal to 18 divided by negative 3, or 6, 12, 18. It is equal to negative 6. Is this solution extraneous? No, because the extraneous solutions would be only if we found that x was equal to negative 2 or x was equal to negative 10, because they're not allowed. And so, since we know that negative 6 is equal to neither of those, it's not an extraneous solution, it's an actual solution, we win. It works.